Hi all, welcome to the video lecture series of object-oriented programming. In this video lecture we will be discussing about life cycle of threads. In Java there is a class named thread which is used to achieve thread programming. So since it's a class, there are several constructors and methods inside that class which helps us to create as well as perform various operations based on threads. The thread class in Java extends the object class. As we all know, object class is the class that is inherited by all the classes in Java. Or in other words, we can say object class is the parent class of all classes. So naturally, thread class is also a child class of object class. And at the same time, thread class implements an interface, and that interface is known as runnable interface. Some of the methods that are available inside the thread class are mentioned here. These methods are required in order to understand the life cycle of a thread. That is why we are going to see this first. The first method is the start method. As you can see, there is no return type. That means this method does not return anything. This method is used for starting the thread. So if you want to start a thread, we have to make use of this method. Then we have the run method. So once the thread is started, what all actions the thread have to do? Those actions must be written inside the run method. Then we have a sleep method. As you can see, it is static. That means this method is shared by all the thread objects. That means for creating threads, we need to extend the thread class, or we have to implement the runnable interface that we will study later. But what does a method is? What does we mean by the static methods? We know that once a method or a variable is declared as static, even if we create hundreds of objects, all those objects will be sharing the same method. A separate method or separate static variable will not be created for each of the objects. So this method actually belongs to the class thread, and all the objects of class thread will be sharing the same method. And this method is used to suspend the thread for a short period of time. So it sleep means it makes a thread inactive, and how much time or how much we have to mention the time for which we have to sleep the thread. So for this method we will be giving a certain input which represents the time for which the thread has to sleep. Then for each thread there will be a priority. So if you want to get the priority of the current thread, we can use the get priority method. As you can see, the return type of this method is integer. That means priority of a thread is actually an integer. If you want to set a priority to a thread that is created by ourselves, we can make use of set priority method. By default, every thread has got a priority, but if you want to remove or if you want to update that priority to some other value, we can use set priority method. The priority comes to play when multiple threads are trying to access a shared resource. Suppose there is a printer and all the threads needs to access the printer at the same time. At that moment, the thread which has the highest priority will be given the first chance to use the printer. So priority are used for determining which thread to work first. If all the threads are having the same priority, then the actions will take place on a first come basis, on a first come first served basis. And next method is stop method. This method is used to stop the thread. So these are some of the methods available inside the thread. Now we will see the life cycle of a thread. A thread goes through various stages in its life cycle, and this figure shows the sum of the stages, or this figure shows all the stages through which a thread goes through in its life cycle. A new thread will be, when we create a thread, it will be in the new state. From that new state, the thread starts, or thread will be in the runnable state when we call the start method. So all the thread that we create will be initially in the new state, from that state, when we call the start method that we have seen in the previous slide, the thread will be moved to the runnable state. So here the thread is ready to run, but it is waiting for the CPU scheduler to call it. So all the threads that are ready to run will be in the runnable state. Once the CPU selects the thread, because CPU is the main person which allocates the resources for a thread to get executed. So when the CPU selects a thread, then it will be in the running state. So for the thread to move to running state, it has to be done by the CPU as well as the run method of the thread. So in the running state, all the actions in the run method will be executed. And when a thread is in the running state, if some sleep command or sleep method is executed, or if the thread needs to use an external resource, or if the thread is waiting for an input from the user, so it has to wait for some time. In that case, the thread will be moved from the running state to non-runnable or blocked state. That means the thread was running properly, but all of a sudden the thread required some input from the user, but the user is not available right now. Or in another case, we call the sleep method or suspend or the wait method. We will see what are they, but whenever we call sleep or suspend or wait method, or if the thread is waiting for some input resource or input data, or if the thread is waiting for some resources like memory or some printer, etc., at that moment the thread will be moved from the running state towards the non-runnable or blocked state, because the thread cannot proceed further without getting the input or without the sleep method is over, because we are forcing the thread to sleep for certain amount of time. So in such cases it will be moved to the blocked state. Once the time that we have specified to sleep is over, or if the input for which the thread is waiting, once the thread gets the input for which it was waiting, or once it gets the resources that is required for it to complete the work, then the thread will be moved back from the non-runnable or blocked state back to runnable state, not to running state. It is moved back to runnable state. So now the thread is again runnable, that is ready to run. Then again the CPU's scheduler will select the thread, then it will start working again. Once it completes the work, all the work required to do by the thread, it will be moving to the terminated state. That is a final state where the thread stops its working. So this figure entirely shows the different stages of the thread life cycle. This is the figure. These are the explanation of each of the stages of thread life cycle. A thread is in the new state whenever we create an instance of thread class. That means when we create an object of thread class, but before we call the start method. Runnable, that is, a thread is in the runnable state after invocation of the start method. That is, once we create the thread object, if the thread wants to start its working, we need to call the start method of the thread class. Once we call the start method, the thread will be moving to the runnable state, and the thread scheduler, which is inside the CPU, will be selecting the threads from the runnable state. Okay, so all the threads inside the runnable state will be ready for running. That is, we have called the start method, but it's not selected by the thread scheduler. It is waiting for the thread scheduler to select it. So all those threads which are ready to run will be inside the runnable state. Once the thread scheduler selects the thread starts running, then it is in the running state. Then if the thread is waiting for some input, or if the thread is waiting for some resources like memory or other output device like printer, etc., depending upon the program, or if you are asking the thread to sleep for some time, in such cases the thread will be moved from the running state to the blocked state. So blocked state means thread is alive. Thread is not dead, it is alive, but it is waiting for some reasons. But that means it is not currently, it's not eligible to run. That's the meaning of it. So the thread is waiting for something, or it is forced to wait for some time. So in all such cases, the thread will be moved to the blocked state or non-runnable state. And the last state is terminated, which means the thread completes its work and it is stopped permanently. We shall conclude now. In this video lecture, we discussed about thread class in Java. What are some of the methods inside the thread class? And also we discussed about life cycle of thread, different states through which a thread moves in its entire life cycle. That is all in this video lecture. Thank you so much.